Hello and welcome to the SAF Amateur Radio Club Foundation Licence Training. This is the first set of slides for the welcome section, and we're going to talk about the background of amateur radio, the radio spectrum, frequencies and modes. There's very little mathematical requirements in this, so don't be worried about anything being tricky, and we'll go through at a nice steady pace. And if you have any questions or difficulties, then please see us on the evening meetings to help work through them, or email us directly. So let's begin. So what is amateur radio? Amateur radio is for self-training and experimentation. It's non-commercial, so you cannot use it for business or commercial use or advertising. It is a recreational activity, and it promotes technical innovation, development of skills, and international friendship, among other things. The foundation licence is the first of 3 UK level licences. There's the foundation, the intermediate, and finally the full licence. The history of amateur radio dates back over 100 years now. Amateurs were heavily involved with reception of enemy messages in World War II. Originally, they used Morse code, and then voice came about later. They were used to save lives in the 1953 floods, and they played an important part in the 1982 Falklands War as well. Amateur radio today has over 2.5 million licensed amateur enthusiasts worldwide. The top countries in the world are Japan, the US, Germany and the UK. Amateurs use voice, Morse code, data, images and video, plus there's internet links as well. Worldwide activities are contests, de-expeditions and JOTA, which is a scout event. They take part in emergency services help as well under the RayNet banner in the UK, and they have access to space with the amateur radio satellites that are on the International Space Station, among others. Amateur radio activities. So, this is a great hobby for making friends, experimenting, field days, contests and competitions, collecting QSL cards, rallies, nets and training. So there's a wide scope here in the hobby. The radio spectrum itself, the frequencies, are broken up into chunks. The types of industries that use these chunks are broadcast radio and TV, mobile phones, emergency services, military, aviation, maritime, space exploration, businesses and taxis, satellites, GPS, Wi-Fi and Bluetooth, baby monitors, cordless phones, CCTV and security systems, and PMR and walkie-talkies as well. All of these different industries have a slice of the band, so with all the frequencies available, they're chopped up into little pieces as you see on the diagram here and allocated for different purposes. Today we're going to talk about 3 particular slices of this continuous band. We've chopped them up into 3 individual pieces as you can see here. And the first section, from 3 MHz to 30 MHz in frequency, is the HF or high frequency band. The VHF, which is 30 MHz to 300 MHz, and UHF, which is 300 to 3000 MHz. VHF is very high frequency and UHF is ultra high frequency. So these are a general abbreviation of the typical numbers or frequencies of that band, as we call it. And you won't need to know in detail this, but remembering HF is 3 to 30, VHF is 30 to 300, and UHF is 300 to 3000 MHz. May be a question that comes up. The amateur allocation, so we have our own section of the bands Radio amateurs have several frequency bands, in fact, that we're allowed to use. The tables published in the Foundation License Manual, and with the exam you'll get a copy of this. Some frequencies are shared with other radio users as well. We're not allowed to cause interference with other services. Please bear that in mind. And the display that you see on the right there gives you an idea of the slots or sections of the band that we're allowed to use for various different purposes. One thing to understand is frequency and wavelength. Amateurs refer to the bands by frequencies and wavelength. A VHF frequency of 145 MHz has a wavelength of 2 meters. So if you imagine waves on an ocean, the wavelength is from one wave to another. So you could measure it from the peak of one wave to the peak of the next, or the trough of one wave to the trough of the next. Those distances will be equal as long as you're picking the same part of each wave to measure from and to. So this is the wavelength. So a particular frequency will have a particular wavelength. As the frequency increases, the wavelength is reduced. So over a set distance, as you can see here on the left hand side, we have low frequency, meaning long, gentle waves. But as those waves become more and more frequent, to the higher frequencies, there's a lot more waves in that short piece of distance. So as the frequency is higher, therefore the wavelength is shorter to fit them all in. So they're inversely proportional to each other. High frequency, short wavelength. Low frequency is long wavelength. So if we look here, there will actually be a chart provided during the exam that you see on the right hand side there. And this line across the chart gives you a way of converting the wavelength on the left hand axis of the graph to the frequency along the, and vice versa. If we looked at 7 megahertz along the bottom, tracking up and going across, it would go to the 40 meter wavelength. So we're just following along and down or up and across to find the different values. On VHF, you'll notice 145 megahertz along the left hand, along the bottom here. So 145 megahertz, which is roughly halfway between 100 and 200 megahertz. If we go up from there, we'll hit the diagonal bar and go to the left, and that comes out at 2 meters. And in UHF, we have 430 megahertz, so just after the 400. If we go up and across, that translates to 70 centimeters, which is in between the 0.6 and the 1. So this is something to bear in mind and become familiar with, because they usually ask a question about this type of conversion. One of the things you can do is physically draw a line across and down using a ruler, and therefore it will allow you to be more accurate and make sure that you're getting the right answer. Some of the values are common bands that you will hopefully know of with a bit of experience anyway. Modes and modulation. There are several types of communication in amateur radio. We can use our voice through the radio. We can use Morse code, or CW as it's also known as. We can use data, and we can use SSTV, which stands for slow scan TV. There's also FM, AM, continuous wave is CW, which is akin to Morse, SSB, single sideband, digital voice, and different data modes as well. So the 4 top items mentioned there: voice, Morse, data, and SSTV are the different modes. And the bottom items there are the type of modulation. And we'll go into that in a bit more detail in a bit. So to summarise these slides for the welcome slides, The three different bands that you need to know are the HF band, which is 3 MHz to 30 MHz, the VHF band, which is 30 to 300 MHz, and the UHF band, which is 300 MHz to 3000 MHz. These numbers really just need to be committed to memory. The spectrum, bear in mind we have to share the frequencies with other users, and we need to be able to use the tables provided in the exam booklet to look them up. The frequency and wavelength, again, bear in mind the higher the frequency, the shorter the wavelength, and we need to be able to use the conversion chart provided as we just did. So a nice gentle start. If you have any questions at all, please contact one of the tutors and get your questions answered.